Observe the waveform, this is graph of current varying with respect to time, this is given in milliseconds. You can see the wave looks like a sine wave. It goes up and down. And so the current, alternating current, is described as sinusoidal. If you look at that during the first half of the cycle, which is 0 to 10 milliseconds, the current is positive, and in the other half it's negative. What does it mean? This means that current flows alternately one way and then the other in the wires in which it is traveling. Wherever you use a mains appliance, that means the appliance that's connected to the mains power supply, current flows backwards and forwards in the wires between you and the power station from where the power is being generated. You can observe that at any instant in time, the current has a particular magnitude and direction, as you can see from the graph. It has a maximum or a peak value of 2 amperes at t is equal to 5 milliseconds, and a minimum of negative 2 amperes at t is equal to 0 milliseconds, as well as t equal to 15 milliseconds. So the following questions, what we can see, they are related to the graph shown. If someone asks, like, what's the value of current when the time t equals to 5 milliseconds, and what's the direction? So I of 5 is 2 amperes, as you could see from the graph, and it's in forward direction. At what time does the current next have the same value but negative? That is t equal to 15 milliseconds. What is the time t for one complete cycle? The capital T time period of any sine wave is between peak and peak or crest and crest. So that's t is equal to 20 milliseconds. What is the frequency of the alternating current? From the graph, we can make out that there is one cycle of positive and negative in 20 milliseconds. Therefore, in a second, that means in 1 second, the number of cycles are 50. So the frequency can be said as 50 hertz. Hertz is a unit for the frequency. So it is but common to represent current with I equals to I max sine omega t. It is used to represent the alternating current. I max being the peak or maximum current, and omega is the angular frequency. Angular frequency is given by 2 pi f, where f is the frequency, and in the above graph f is 50 hertz. Therefore, omega is 314.16 radians per second. So it turns out that when you substitute these values, I of t is equal to 2 sine 314.160. So as one could guess, similar to current, EMF generated could also be sinusoidal, which is a sine wave in nature, and this equation could be V of t is equal to V max sine omega t. Power generators, from where we get electricity, generate alternating voltage, and it could be like V is equal to 300 sine 100 pi t, which has a maximum or a peak voltage of 300 volts, and omega is 100 pi, which gives you F equal to 50 hertz. How do we measure all this? Peak value, frequency, and all the things. Oscilloscope, or to be precise, CRO, cathode ray oscilloscope, is used to measure the frequency and voltage of an alternating current or voltage.